All right, welcome everyone, and thank you for joining us. I'm Brenda Dittinger from BIOPAC, and I will be your moderator on today's webinar, Tools for Studying Driver Psychophysiology. Today's webinar is being recorded, and we'll send each of you a link once it's processed. During the webinar, if you have questions, please submit them to me through the control panel. That's how you communicate with me, your moderator, and I will pass as many questions on as I can to the presenters. Just so everyone knows, we host a biennial human physiology training event, and registration is now open. We'll be hosting this event again in July of 2025. It will be at UC Santa Barbara, and we'd love to have you join us. It's a great opportunity to get hands-on experience with all the BIOPAC places, including the ones on today's webinar. Here are just a few of my favorite photos from the 2023 event. So hopefully we'll see some of you in California this summer. Now, on to our presenters. I'm excited to introduce Alex Dimoff. He's our product expert and the head of sales for Europe. He has taught over 125 workshops on the topic of physiological data collection, data acquisition, and analysis, and has been with BIOPAC for over 15 years. While at UC Santa Barbara, he was an instructor for the Advanced Training Institute for Virtual Reality and Social Psychology. Welcome, Alex.
Thanks. Welcome, everyone.
We also have Dr. Sanjay Sood. He has his PhD from All India Institute of Medical Sciences, New Delhi. He has over 32 years experience working with a diverse medical student population as a physiology teacher and researcher. He's currently a consultant with BIOPAC. Welcome, Sanjay. All right, Alex, let's start with you. I'm making you presenter.
Okay. All right. Thanks, everyone, for tuning in for this webinar. We have quite a lot of things to cover, so I'll get right into it. But I just want to say a few words about BIOPAC. Currently, over 99% of the top universities in the world run BIOPAC systems. And there is a tremendous amount of publications using our equipment, over 55,000 publications and counting. And what we are doing is providing a multimodal data acquisition platform. So currently, our software called Acknowledge can record data from lots of different devices, eye tracking, glasses, bars, mobile wearable devices, brain-computer interface, cameras, VR, face recording, EEG, and functional near-infrared. And of course, our main data acquisition platforms for recording various physiological and biopotential signals like the MP200, which is the latest model. We have several data acquisition platforms. And the MP200 is a multi-channel device. You can then additionally connect wireless modules to record signals like ECG, skin conductance, EMG, etc. They can be wired. Here on the bottom, we can see our wired amplifiers, which have been out there for over 30 years. Then we have the newer generation smart amplifiers, which are very lightweight, very high signal quality. And we have other ways to bring signals in, like using analog input, also analog output, and then digital input and output. And then we have all these ways of stimulus delivery. Stimulus presentation platform built right into the software. So you can present images, text, etc. Virtual reality, which we'll talk about separately in this presentation. Also electrical stimulation, so you can deliver voltage, current stimulation to the participants, and also other senses, thermal stimulation, olfactory stimulation, and haptic stimulation. Now, here are the building blocks for what we're going to go into today. If you're outfitting a lab to study driver psychophysiology, there's so many tools that we can provide. So here is a list. We have eye tracking, fNIRS, functional near-infrared spectroscopy, EEG, wired and wireless physiology. We have the new research ring right here, options to record and synchronize with media, the face reader for looking at facial expressions, virtual reality. Now, of course, these are the tools, but what people want to get to are specific states of the driver. So people want to find out about behavioral states, performance, uh, perception, cognition, physiological states, and emotional states. And this is essentially what we're using all these tools for. So that's kind of the bigger picture. But of course, after covering this big picture, we'll go right into the specific tools available. So just a bit of an overview. If we look at behavior, performance, it may be things like whether you're keeping in your lane, whether you're having good reaction times, whether you're keeping enough of a gap between you and other cars. And if we're looking into perception, then it may be looking at how you're able to deal with like visual clutter if there's lots of distractions and vehicles and pedestrians. Also, where you're looking, for how long you're focusing, whether you're able to anticipate hazards. Then cognitive states of the driver, so related to workload, attention, memory, and decision making. What happens if you're multitasking, if you're maybe listening to music and you're driving, looking at mental fatigue. So while you're driving the car, you at some point may have a judgment impairment because you are mentally getting fatigued, which is a bit different from physical fatigue. And then, of course, physiology. So looking at things like heart rate variability to get at stress, workload levels, and electrodermal activity, which is related to the sympathetic nervous system, muscle fatigue. So if we can look, for instance, at the impact of the comfort of the seat where you're in, and on and on. And then on as far as emotional states, of course, what mood we're in may influence our driving behavior, or we may be interested in knowing whether a specific driving experience or a car is changing the mood of the participant. And things such as frustration, aggression, which may affect what happens in a driving situation, would be much more meaningful if we have an insight into the emotional states. So we'll get into that. And then I want to also say that we have different scenarios where one may study driver psychology. So there may be driving in the real world, where in the car, on the streets, but it could also be driving on the desktop. You're in front of a monitor and you are using a keyboard or a joystick. We'll do that as well at one point. So we have a joystick ready right here. Steering wheel and pedals, which we're not going to use. There's not enough space for this here. You can have like a 2D driving simulator. We could be using virtual reality. We have the HMD ready over here for firing up virtual reality. Or you could be watching other people drive, as illustrated in this AI-generated picture that I just had generated before the webinars for a bit of a laugh. Now let's begin with the first item, eye tracking glasses. I think eye tracking is probably one of those things that most people are interested in as far as studying driver psychology. And some of the common metrics are related to dwell time percentage, which may indicate how much resources we're allocating to a specific part, maybe the road or some instrument cluster. Fixations, so what are we looking at? And pupil diameter, which has been used to get at cognitive workload. And saccades, which are the fast movements of your eyes. Now, the eye tracking glasses that we have, they have 180 hertz sample rate, which is a pretty good sample rate, and that enables things such as saccade analysis. There is a sun shield for outdoor use, which is important if you're going to be doing experiments in the real world. And participants can wear sunglasses underneath, and they're rugged, which is not to be underestimated. Long battery life, so you can go for a very long drive. And we can also provide real-time area of interest detection, and that can even be used for biofeedback. So, if you're spending too much time looking at the entertainment screen, we could get this information in real time and provide feedback to the driver. And the glasses can be used in 3 different modes: over Wi-Fi, Ethernet, or in logging mode. So I'll show you here an illustration of this live object tracking using AI, where you can even define your own custom objects. Okay, so here we can see, first of all, on the top, we have the eyes as they're tracked by the eye tracking glasses. And then underneath, as the person is driving, we can see that the AI-driven algorithms are detecting in the scene view objects and areas of interest, like the left side mirror, right side, rear view, etc. So what happens is that we can get information in real time, as well, of course, post-acquisition, about what the person is looking at. So you don't have to manually analyze the data, and this is a very big deal. Now, we can, of course, synchronize that data with physiology. So here I have an example using our bioinformatics logger, which Sanjay will mention a bit later in the presentation as well. It allows connecting wireless modules. In this case, we have electrodermal activity, ECG, and accelerometry, and it can be synchronized with the eye tracking glasses. So we can know where we're looking, and we can see the physiological responses. So the cursor is actually linked between the physiological data and our eye tracking recording. Okay. I just wanted to also point out that because we have a built-in accelerometer inside our logger, we can verify synchronization by literally having our accelerometer in front of a camera. This is a bit of a practical tip, and tapping on it while you're recording eye tracking, so you can make sure the synchronization is aligned and don't rely only on time tags. And now let's say you're using our acknowledge software, which is the most common scenario for people doing sort of driver experiments. Now, I wanted to show you here, the context is not driving, but it's easy to explain this way what we're talking about. So we have here the software controlling the eye tracking glasses, which is directly linked into our acknowledge software. So all the data can come in alongside physiological data recording. And we can see now when the participant looks at objects like laptop, keyboard, whatever has been defined here, markers are arriving in our acknowledge software. We can see now here a list of the markers, and then these on the top here are the events related to that. And then we can also see in real time a percentage of how much time is being spent looking at different objects. So everything is completely integrated and that makes a huge difference when you're going to be analyzing data, because in our software acknowledge, you can perform event-related analysis based on these areas of interest and other event markers, like when things happen, when there was a collision, hopefully not in the real world, but in a simulation, or a pedestrian was crossing the street. And then you can explore the relationship between eye tracking and physiology. And in the software that is dedicated to processing eye tracking data, you can perform the pure eye tracking analysis, doing things like looking at the correlations of, like, if you're looking at the instrument cluster, are you then likely to look at the road or at the steering wheel or something else? Just a whole lot of data that you're getting out of. So there's different ways to analyze data. Now let's go and move on to our first poll.
All right, thanks, Alex. I'm gonna go ahead and launch this poll. And we're wondering if you're currently conducting driver psychology studies. And we did have a couple questions while that poll is getting answered. Do the glasses have a road-facing camera, or is there a way to set that up?
You mean rear facing or?
Road
Oh
facing,
yes,
like
yes, yes, absolutely, absolutely. There is a scene camera that is looking out, right? So that's how you know what you're looking at. So that you're always recording the scene, essentially, right in front of you.
okay, great. Okay, so then let me take a look at these results here. It looks like 26% of people are yes, 14% of people no, 25% of people planning to in the future, and 36% of people are interested in learning. So maybe someday in the future, you all will be able to adopt this technology or use this technology for something else. Okay, so I'm going to go ahead and end the poll, and then I go back to you,
Yep,
Alex.
yep.
Okay, there you go.
All right, thanks, Brenda. So the next uh, tool in our arsenal will be functional near-infrared spectroscopy. And some of you are probably familiar with it, but I'll say a few words so that everybody can be on the same page as about concerning what it means. Okay, um, what we are exploiting here is the fact that when you have neuroactivity in the brain, you need oxygen. Neurons need oxygen to metabolize glucose. So there is some activity in some part of the brain, and then what happens is you see changes in oxygenated hemoglobin and deoxygenated hemoglobin in that part of the brain. And we're able to capture that, these correlates of neuroactivity. And the way we're doing that is oxygenated and deoxygenated hemoglobin. You can see here in this bottom picture, they have different absorption factors for different wavelengths of light. So if we shine two different wavelengths of light through the skull, like right here, so we have a source, and then we have a detector. We have detectors at fixed distances from these sources. Then oxy and deoxyhemoglobin, they will absorb different parts of the light spectrum, and then we can essentially see what are the changes in oxy and deoxyhemoglobin. And what happens is this is a hemodynamic signal, so this is no longer the neuro signal. So when we record EEG, we get the electric signal, but here it's a hemodynamic signal. So we present the stimulus, and there's usually a bit of an initial dip in oxygenation as your neurons are essentially performing some activity using up oxygen, and then there is an increase in oxygenation, and that happens because microcirculation changes happening in the brain are then resulting in basically more oxygen being delivered to the area that is active. It's very similar to the bolt signal in the MRI. Okay, so we have a hemodynamic signal. It takes a few seconds from when activity is beginning to when we see a change. This has been used. Uh, it does already with car studies quite a bit, looking at things like cognitive workload, fatigue, drowsiness detection, tension, distraction, and decision making. Um, and we can look at the prefrontal cortex. So we can see here there's 16 channels with this particular system. So we can look at changes in the prefrontal cortex. For example, there's one experiment where as people are using autonomous driving, they are engaging in other tasks, and then we can see what happens, what are sort of the changes in cognitive demands as they're maybe watching a movie or reading while they're driving. So we shouldn't do that, but that's example application for that. So already several of the big manufacturers have used our systems in research, so not only academic research, but our system is also used by car manufacturers when they perform experiments with their cars. And we essentially have two different kinds of systems. So we have a prefrontal cortex system, You can see here, and usually all of these you wear something on top, but we're showing pictures without that, so you can see what the actual systems look like, but you have to cover the ambient light. So I want to be very clear, this is an important point when we are conducting experiments with functional near-infrared, because we're looking essentially at changes in infrared light, so we need to block out the sunlight. Okay, so here we have this sensor, and then we can also use it in VR with a special under helmet sensor. And then we also have this full head system, which can give you lots and lots of channels and also can be used in VR. So let's look at sort of the differences between the two different kind of systems. Different fNIRS systems will be appropriate for different experiment designs. So this prefrontal system is very lightweight. It's about less than 50 grams or so for the sensor. You can set up everything, get up and running in a couple of minutes, very easy to use. And there is a pro and con here with a fixed layout. So it's a fixed layout, that's why it's so easy. But also, of course, if you need a lot more flexibility, then you have to look at the other option that we have. And then there's also complete analysis workflow, including down to the statistical analysis. It's already used in over 500 publications. And as I mentioned, we have this special under helmet sensor. And the unit can function wired or wireless as far as connection to the computer. And then if you're going wireless, you can just have a battery pack, external battery pack over USB-C. So very flexible. Now, let's say you want to go much deeper in terms of how much you want to measure from the brain. We have a high density fNIRS and also fNIRS plus EEG system. And it can be worn for a very long time. Both systems can be worn for a very long time, but this is particularly comfortable. So we've had people use this for up to like 6 hours driving with the system. And because it's an exoskeleton-based design, it's very comfortable. It may look a little bigger, but that's what you get out of it. A very big positive is this high comfort. And then it can also block out eye trackers pretty well, eye tracker interference, which can be an issue if you're using fNIRS. So by using a special cap, can do a pretty good job at blocking out eye tracker interference. And then you have some unique points like direct access to the scalp for removing hair that is in the way. Because this is not a cap-based design, you can easily remove any hair that's reducing the quality of your recordings. So it's a very flexible layout. You can shift around these emitters and detectors in any configuration you want, and also works with VR. EEG is running on the same hardware, and it's a modular system that it can go from 8 emitters and 8 detectors all the way up to 16 emitters and 32 detectors, so truly high density system. So we actually have a webinar coming up. I believe it's next week. Brenda will let us know if it's next week or the week after, but specifically looking at optimizing the montage for fNIRS and EEG with the system. Now, synchronization is always the big deal, right? So how do we connect it to all the other tools? And of course, with Acknowledge or anything else you may be using. So the prefrontal system, we have a BNC trigger. We have the ability to receive markers via network, serial paddle port, keyboard, and then also send data in real time over the network. And we also have VR integration for biofeedback. And with the full high density system, we actually have it integrated with Acknowledge. And we have in the works VR integration for biofeedback and ability to use API for real-time data. So really, you have excellent options here to get everything synchronized and don't have to worry about that puzzle. Let's move on to a related technology, which is EEG. and a headset that specifically has been used quite a bit in driving research is the B-Alert headset. Again, directly integrated into Acknowledge. It's minimally invasive. As you can see here, we're looking at a very thin strip electrodes. They're printed electrodes that are very easy to set up. If you have used EEG before, it can take a bit of time to do it, but with this system, it is quite quick, and it also has built-in impedance checking. So if you see you have a problem, maybe like somewhere here, there is a weak signal, you can lift it up. There is a Velcro attachment. You can part the hair, maybe add some gel, and stick it back on. So if you have some issues, very easy to troubleshoot. And then we have 9 and 20 channel versions of it. And there are cognitive state classification metrics. Basically, you can look at engagement, confusion, distraction, drowsiness, workload, etc. So this is going a step beyond just having the EEG. Again, all of that is natively recorded in Acknowledge, and we have these cognitive states available as channels. Here I have a screenshot, some data that I recorded for myself, and I've used just a few of the cognitive states so we can fit it more easily on the screen. So we can see high engagement, low engagement, distraction, drowsiness, values going between 0 and 1. Very important point is that when you're using these cognitive states, you do need to do a baseline calibration for each participant, and depending on which routine you use, it will take 3, 5, or 20 minutes. So you're going to have to do this not in the car, but you're going to have to do this in front of a computer. But the good thing is you can reuse this for the same participant even a year later. If you're doing an experiment on the same participant, you can reuse what we call a definition file that you created during the baseline testing. I would say quantifying fatigue is a very common application. This has been used for studies by the Driving Safety Research Institute. And here there are some sample publications. If we're sharing the deck afterwards, I think then you'll be able to grab those. I mean, you can always grab those from the recording as well. We have other traditional EEG options. These are our amplifiers that connect to the MP200 and also to a logger and other systems that we have. So we have a wired amplifier, traditional one, the smart amplifiers, wireless, and they can connect to an electrode cap, or we have a new cap that we started offering, which allows you to place electrodes and then fix them in place with the cap, and you have these nice big holes which give you access to deal with hair. So we can, if you want to have a lower density solution, you can talk to one of the BIOPAC reps about how to configure that using just a few amplifiers. And then if you want slightly higher density, there's 24 and 32 channels EEG wireless and logging systems that we can use. Now let's go on to our second poll and then off to Sanjay. Thank you.
All right, great. Thank you, Alex. And let me get this poll going here. Okay, here you go. What signals are you collecting in your research? And I have a question about fNIRS. How long can you comfortably wear the fNIRS, either fNIRS headset?
Yeah, so the full head one, you can wear it for quite a long time, and also, of course, the prefrontal cortex. I know it has been used in published studies for people walking around a campus, as well, of course, as driving. So, I mean, both of these are very comfortable. I would say with the prefrontal one, the main thing is not to tighten the band much. Just make sure you cover up very nicely. Because sometimes when people are setting up, they like to tighten a lot, but just don't make it so tight. Instead, cover nicely the sensor so you don't get light leakage, and then you'll be able to go on for quite some time.
Okay, great. Well, the majority of people here are using eye tracking, EEG, and other physiological signals. And then fewer people are using fNIRS and facial coding, but that's a great opportunity for you guys to start working on those technologies and those signals. All right, now I'm going to move on to Sanjay. Sanjay, I'm going to make you presenter. Here we go.
Yep. Can you see
All
my
right,
slides, Brenda?
looks great.
Okay. So, hi guys. So, I'll be talking about wired and wireless solutions for such research. As you know, the hub for recording and acquisition is MP200 system. It's the picture is shown here, and it comes with a very robust acknowledged software. And if you see on the other side, there is another module which is attached. It is known as AMI 100D. In fact, you can record around 16 analog biosignals in addition to digital and calculation channels. Now, once you have a acquisition system with you, the next step would be to decide whether you want to go for wired or wireless solutions. So each has its own merit. Definitely for outdoor, driving realistic states, you need wireless to avoid any accidents. But if you're doing some research in simulation or in the lab, you can use wired solutions. And also, it also depends on your budget. So we have both wired and wireless solutions for doing such studies. For wired ones, we have smart amplifiers. If you see, these amplifiers are really very small. And if I have to give you little comparison, here is a smart amplifier. Can you see my screen, Brenda?
Yes, I can see your smart amplifiers. Yes.
So this is the small amplifier I'm showing here. Whereas if you have to compare it with the last generation of amplifiers, this is how big it was. So these amplifiers are really very small, very light, comfortable, and they can be easily attached. If you see here, I have attached one here and also attached over my chest. So these are really, they can be easily clipped near the recording sites. And of course, they have very high signal to noise ratio, and they're very user friendly. So they can be easily connected to the module and no need to set it up. Once you connect, the acknowledge automatically detects them. So this is regarding the smart amplifiers. And as Alex showed in his first slide, you have many options. So depends on your research design, precisely what exactly which signals you are picking up. Could be EEG, EOG, it could be EDA, EMG, you name it, and we have the amplifiers to pick up these signals. Now the other one is the wireless ones. So we call the modules as bionomedics. So here is a bionomedics module which picks up respiration and ECG. So technically each wireless bionomedics module picks up two channels. And this is the transmitter which is attached to the body of the subject. And then on the other side, we have a receiver module which is attached to MP200. So this is in case you're doing in lab or when you're inside, like doing simulation studies. So you can use this kind of scenario. But suppose you're recording on the go outside, right? In that scenario, you have many options. So either you have smart center. This one is the small module which acts like acquisition and analysis part of the signals it picks up. And then you have a logger. As Alex said, the logger is also of great advantage for doing outdoor, out of the lab recordings. And in case all these bionomedics modules, they can talk to either the logger, the smart center, or they of course can also talk with the help of receiver to MP200. The connection is very simple and straightforward. So you see here in the middle, there is MP200 unit with AMI module. In between is the bionomadics receiver. And on this side, you'll see the subject is tied to the bionomadics transmitter. And then you have electrodes, these which can be easily clipped to the, these leads which can be easily clipped to the electrodes. So that depends on the study design, what kind of study you're doing, whether you're using facial, so you need facial electrodes and all kind of electrode choices we have with BIOPAC. Now, this is what Alex was talking, it's a logger. Logger is very good when you're going out of the lab. So it can record all the signals which are coming from the bionomatics. So it depends how many channels you are linked to. And then this can also be, tagged to a external GPS module, so that as for synchronization, as Alex was mentioning in his one of his slides. And at the same time, the researcher or the subject can also put in some synchronized audio notes and also mark events for later uh, analysis. And it's really very small, it fits in easily in the pocket. The best part is the operation time is around 24 hours if it's fully charged. And of course, you need to have one external GPS module to kind of make it for tracking for GPS location. So yesterday we did some recordings, and here if you see, I'm tied for ECG, respiration, and EMG. For ECG, I'm using a respiratory and ECG bionomatics module, which is tied to my chest. And if you see, the ECG leads are picking up from the precordium. So I'm picking up lead 2. And then I'm also picking up using EMG bionomatics module. I'm picking up just for demonstration trapezius EMG activity. You can also pick up for studying the facial effect. Maybe you can pick up from the corrugator or zygomaticus. So depending on your research design. And this is what the setup is. And then this is to give you a top view that how you put the various equipments and how the researcher and subject is comfortably placed in the car. If you see in the back seat behind the driver, there is a tray where the battery and all the modules like MP200, and there are 2 modules, bionomadic receivers here, and then of course there is battery. The researcher will be sitting behind on the other side, and will be controlling all the activities, guiding the subject. So it can also record, acknowledge, and everything. Whereas the subject will be seated, and depending on your research design, you'll be picking up various biosignals. So here there is a realistic scenario of the recordings. It's simple and straightforward. BIOPAC offers a very simple, straightforward solution for doing driver psychophysiology research. And these bionomatics modules are very handy. And as I told you, most of these gadgets are literally play and plug. So you don't need to set up various values in the acknowledge software. Now, if you see, when we are recording these peripheral physiological signals, so the importance of various biosignals is, for example, by looking at ECG, you can record heart rate or heart rate variability, which in a way will tell you about maybe stress, or it can also tell you about paying attention. Then EDA, another very important signal. So as Alex was showing, this is also very important, electrodermal activity or sympathetic skin conductance. So you can pick up from various locations depending on your study design. Suppose your hands are free, then you palmar surface of your fingers, and also maybe thinner and hypothinner muscles. Then you can even pick up from forehead, neck muscles, back, shoulder, And like that, there are around more than 16 standard sites for picking up EDA. So it depends on your study design. And especially in driving, it will be better if you put them behind, maybe on the shoulder or the neck. Then respiratory signals, respiratory chest movements can be picked up using bionomadics module with the chest belt, which I'll be demonstrating soon. Like you can pick up trapezius, corrugators, zygomaticus to quantify effect, which is even better than doing using face reading softwares. Then of course, Alex has already talked about eye tracking, EEG, research string, and fNIRS metrics. Now, another very important thing, especially for outdoor, when you're in the go and recording these bio signals, is the duration of recording, which is possible. Like in case of bionomadics modules, these ones, you can record for 72 hours once fully charged. Similarly, be alert around 19 hours, which is very important, especially when you're doing long-term studies and maybe you're doing sleep deprivation and studying then car driving, things like that. So it has long operation time. Then eye tracking glasses around 5 hours, and fNIRS, it depends on the external battery, how much is the backup. Medalopt, as Alex mentioned, around 6 hours. Logger, this is also around 24 hours, and another very good thing is it can be charged while you're using it, so that can prolong the operation time for logger. Research ring 8 hours, and BIOPAC offers external battery BAT 100A. So in case you're using MP36 systems, you can use 4 sensors for 26 hours, and if you're using MP system, 4 modules up to 16 hours. It has quite a long operation time. Most of the study usually you'll be able to conduct within this operation time. Now, what I'm going to do is I'm wired. You must be wondering that why I have a jacket on. So basically, I'm all connected here. And if you see, I'll show you quickly. Here, I have MP system. So MP system, MP 160 I have. Then we have bionomadics receiver for respiration and ECG. Then I have AMI 100D, where I'll be picking up the wired biosignals, maybe PPG and EDA. Let me keep the camera back. Brenda, am I in the focus?
Yes, you are. Looks good.
Yeah. So now if you see here, what I've done is this is bionomadics module. It is transmitter for respiration ECG, and it's connected to a respiratory belt. So it'll give me respiratory rate, whereas the other one is connected through these leads to my precordium. So I'm picking up lead 2 ECG. And here if you see, I'm connected for PPG. It'll pick up the pulse, and this one is for EDA response. So I'm wired for this. So I have wired and wireless options. So let's see one by one. So okay, so let's talk about the first channel and start recording. If you see here, this is the pulse which is being recorded. Let me stabilize my hand. Okay, now this is the first channel. Let's go to the third channel. This is my respiration. Sorry, this one I should switch off. Let me, yeah. So this is respiration. And the last one is ECG, which is lead 2. And if you see, the second channel is my EDA. So let me also switch on respiration. Let me relax for a minute. Now what I'll do is I'll take deep breath in. So here it is. Let me stop and let me change the sensitivity a bit. Although it is adaptive scaling, but it'll be more exaggerated response. So again, I'm doing it. So I'm breathing in. So if you see here, the moment I am breathing in, there is a change in skin conductance response. So if I switch on all the biosignals I'm recording, and here it is. So you have the first channel is recording my PPG, and the second channel is EDA. So you see here, when I'm taking a deep breath, there is a change in EDA response, and the last one is ECG. Now, if you see acknowledge, it offers a very, very detailed analysis of each signal. From each signal, like for example, let's pick up ECG. From ECG, you can pick up, you can make focus areas. Like for example, if you're driving in a straight road, there's no traffic, and you can compare it with the focus areas where you're entering the town, there are a lot of red lights. So you can see the change in heart rate variability in these two scenarios. Similarly, you can also make focus areas and see what is the difference between EDA, skin conductance response, number of responses during simple driving, no stress, no increased attention load, and then as compared to when you're driving in the town. So that makes it very interesting. So this is what I have. So now I'll ask Alex, or maybe there is a poll time. I'll ask Brenda to go for the next poll. Thank you.
All right, great. Thanks, Sanjay.
Yeah.
We'll go ahead and launch our next poll. And we're interested in where you're conducting your research. And okay, and then Sanjay, I have a question that either you or Alex can answer. Can the biopneumatics equipment be connected and synchronized with the fNIRS equipment?
Yes, of course,
Alex.
right. Exactly, yeah. So because the system itself, depending on which one you're using, it will be different ways. If you're using the MedLock system, it's now capable of being controlled directly by Acknowledge, so you'll control everything from the software. So it's just going to be synchronized. And as far as the prefrontal system that we use, that has a BNC trigger, which can be used to very precisely align the data. So we can receive that BNC signal and acknowledge, so everything will be lined up. I just want to say though that even though these things can be perfectly synchronized, how people usually use those is they also send markers specifically to acknowledge, and then if they if they're using the fNIRS sometimes standalone, then they send markers to that, and it's the markers that are important, right? So everything is on the same timeline, but it's important, of course, usually to think of it in terms of markers, event markers. Okay.
Okay. Thank you. And it's just so you can have the results of this poll. Over 80% are in the lab, and this is, you can select multiples, of course. About a third in the field, and almost a third in VR and AR as well. So thanks for participating, everyone. And now we're going to switch gears back to Alex.
Okay. All right. So for this next part, we're moving on to the research ring. And yeah, there are just so many different ways in which we can record physiology in the car. And of course, if you can, using the MP200 or the biomimetic system with a logger or a smart center are the way to go. That's gives you lots of many signal types, lots of flexibility. But there are huge advantages to using something like the research ring, which you can see that's all it is, right? It's very minimally invasive, and you just put it on and it works. There are no consumables. So you could do experiments with a ring where you just give them, have rings out in the field where people can be just driving and recording data. Now, let me just say a few points first about the technical specs of the ring, and then I'll come back to applications. So this is a research ring, meaning that you get raw data and you can record electrocardiogram up to 800 hertz. For that, you do need to connect a lead that goes across the chest. So you may or may not want to do that. Then you have pulse up to 400 hertz, electrodermal activity, again, up to 400 hertz. And then you have temperature and you have acceleration. So lots of data from one little device. And the ring can connect either to your computer. So as Sanjay illustrated earlier, most often there is a researcher in the car that has the computer and everything's connected to it. So the ring can be connected to that as well. But also it can be completely deployed in the field. Like it will connect to a mobile device, specifically iPhone, iPad, or also could be connected to an iMac. And even the Apple Vision Pro has an app for that as well. So I want to then point out that the ring, when you're using it in the field, it can also save data to the cloud. And then the data from the cloud can be accessed directly within the Acknowledge software. That's just extremely convenient. So if we come over here and we go and import data, we see many different types of import data procedures. But specifically for the research ring, we have this cloud navigator. And now I can see a bunch of my sessions, including a driving session that I've done, which I've already grabbed from the web, so you can download here. There's different recordings. Okay, so you can just download them and they will just open up straight in Acknowledge. But I've already done that, and here we have some data that's coming from the ring. So this was me driving car, and on the app, when you're not using the software Acknowledge, but when you're using the app, you have buttons on the app so you can add markers. So I had a marker here when I actually started driving the car, and then I had another marker that I entered when I stopped driving the car. So all that data afterwards just finds its way into Acknowledge. And then I had a few minutes of just resting in the car, and then I was unloading some groceries, etc. Now, I want to show you here what are some of the sort of things we can do with that data. The first three channels are accelerometry. I'm just going to hide them, but they can give you information about when you're turning, for instance, because that will be reflected in the accelerometry data. Then we have some other signals here, right? So we have like pulse, electrocardiogram, etc. So we'll just go ahead and concentrate right now on let's see, we'll concentrate on the skin conductance signal. I want to also show you here, this is very interesting. Actually, yeah, let's hide channel number 6. Okay, so this channel here shows the temperature, and since I was using heating on the steering wheel, we can see how the temperature was increasing over time. So we can get that information as well. Okay, now here we have the skin conductance data, and as I said, this is raw data. Like there is no filtering applied, nothing. So how do we get something like the rate of skin conductance responses over a period of time? When I was driving, for the first part of the drive, it was a fairly straight road, just roundabouts, and then I entered some heavier city traffic. You can already see here that there has been quite a change in skin conductance responses, but how do we quantify that? So first of all, what we can do, we can resample that data, the skin conductance data. So I will go ahead and resample it, and I'll go down to 50 samples per second. This will make the analysis execute even faster. So if you're working with large data sets, I think it's a good thing to do. Okay, so I'll do that. And once we've done that, it's we can also go ahead and apply a low pass filter. So I'll go ahead and apply a low pass filter at 1 Hertz. That's very typical for skin conductance data. So we've done that. And in Acknowledge, we have many different analysis routines for many signals, including, of course, electrodermal activity. And we should go into the preferences first, because data recorded from the ring, the level in microsiemens of skin conductance is the absolute levels are much lower than they usually are with the traditional wet electrodes. Now, there is extremely high correlation with data recorded with our regular bioinomatics equipment. There is data already on that, so it's very high, like above 95% correlation, but the absolute numbers, they will not quite match up. So we have to adjust the settings in the Acknowledge software. Typically in the Acknowledge software, there is a threshold for when we count a skin conductance response. And it's a change in the signal that's what's called the phasic signal, that's at least 0.02 microsiemens. Now for the ring, I'm going to adjust that and essentially lower this threshold. So this is the one thing that I have to make. Okay, and once this is done, I can have the automated analysis take over. So we can locate skin conductance responses. We'll go off of this channel with the EDA data. And then the software will place markers, these blue droplets that indicate a skin conductance response. And now we can do things like, oh, let's highlight the data in the first part of the drive and make some selections. We can count using the event count box, specifically the responses. They can be anywhere. So now we can see there are 6 responses. We can have our duration, 495 seconds, and then we can perform a calculation. So we can take the number of skin conductance responses and divide that by time. And this will give us the rate of skin conductance responses per second. Now, per second, that's, it probably makes more sense to do it per minute. So I'm going to do one more calculation here, and I'll say, let's take that result, which was the last item there, and I'll multiply that by a constant 60. So I'm going to convert from seconds to minutes. And now I have 0.7 skin conductance responses per minute versus 4.3 skin conductance responses in this part of the recording. And quite a bit more when I started unloading things from the car. Okay, now this data can be exported in a number of ways. It can go to what we have here is the journal. So I can take some measurement here and I can hit Control M. It pastes whatever calculations we have here, including that one that gave us the rate of skin conductance responses. And we have other tools like epoch analysis and event-related analysis that we can use. We don't have time to go into that, but the software is suited very well towards automating these procedures. So they can be described as a workflow using our workflow editor. So you don't have to do these steps every time. You can just have a workflow that does it, or use a script. But the script requires more in-depth knowledge, while the workflow is something anyone can do. So the research ring, the reason why you would use the research ring is when you want something that can be deployed at scale, because the research ring is going to cost much less than all the other equipment. If you want to have many of them, many people can be driving, or if you just want to be up and running super quick. These are the steps, and also the data can be visible on a cloud interface. Okay, now let's talk about synchronization with media. This is important as well. Maybe you want to have a camera that's looking at the participant. Maybe it's also looking at some other things like the environment. Acknowledge allows synchronization directly with a webcam that's connected to the computer, but also we have camera systems that can be connected as well. They can be synchronized. In addition to that, you can have synchronization with any third-party camera by using a little LED that we can flash, so we know exactly when we are aligned with the recording. So the cursor is linked in Acknowledge. The cursor can be linked so that you move the cursor in the video and you move the cursor in the physio data, and they're linked to each other, which allows you then to, after the fact, score behaviors by inserting markers. So we can insert markers, like in the very beginning, I was saying that we can have different sort of behaviors that we're observing. Maybe you are incorrectly taking over somebody, and then we can have markers afterwards applied in the data to perform event-related analysis. Okay, and we have additional tools for synchronization using lab streaming layer. We can receive data over lab streaming layer. We have a network data transfer protocol. We can synchronize with audio and analog and TTL. Now, we can also look at facial expressions. The Acknowledge software can record directly alongside all the physiological data from the Notice Face Reader, which will give you the emotional states of the participant, and also will also give you information about what's called action units, so movement of specific parts of the face. Now, as Sanjay mentioned earlier, of course, if you use something like facial EMG, looking at corrugator or zygomaticus activity, that's going to be more sensitive. That will give you changes that are so small that cannot even be detected by a camera. So if you want to look at positive, negative affect, these sort of things will work very well. But if you cannot use electrodes, then you can have a camera. Have one tip as far as placing the camera: just make sure it's at the height of the driver's face, as much as possible, and right in front of the driver, of course, without disturbing the sight on the road. And don't put the camera too low, as that may introduce a bias towards the surprise emotional state. Okay, now the last section will be virtual reality. We have some really cool things to show you for the VR section. So let's have a quick poll and jump into the last section.
Okay, here I am. I'm going to go ahead and launch this last poll. And I haven't shared the slide. Oh, okay, here we go. Okay, so let me just share that I have a slide about this, but BIOPAC can host workshops in your regional area. And so if you have an organization you'd like to bring us on site, Alex goes all over Europe and hosts these workshops. Sanjay does it in his region. We can do it in the US and Asia as well. So, you can collect some people from your organization and attend and host a workshop in that area, or invite people from other organizations as well. Looks like a lot of people are interested in a one-day workshop for sure. And then attending and hosting one-day and multiple-day workshops. So great. Yeah, so I'll have a QR code on a slide in a minute here, so you can always submit a form to us, or you can email us at info@biopac.com. And yeah, all right, well, great. So thanks. I'm going to end this poll, and then back to you, Alex.
Okay. Oh, I'm already showing the screen. That's right. Okay.
Yes, you are.
Perfect. All right. Okay. So, all right. So this is very exciting. We have, for quite some time, had a platform for experiment generation for VR. It's a complete lab. That's a rendering station, an HMD with eye tracking, the virtual reality engine, hundreds of templates, or I would definitely over 100 templates, and essentially minimal requirement to write code. So you can use this platform even without coding. We've done webinars on that, but there's been more work now done on driving and car scenarios. So 360 video scenes during driving in a 3D environment. And then, so I want to show you some of these now. First, I'll begin with a bit of an overview so you can see what we can do at the moment. So here we can see we can load different kinds of environments where you can drive a car. We can make it whether it's change it so it's night, or make it foggy, make it daytime. Very important thing is this is designed to be fully flexible research solution, so it's not like a fixed simulator, right? You can mess with all sorts of settings. So here we can see the speed as well. Now inside we can swap out the car if we want. We can modify it if we want. We can add. Already we have a browser for different models that you can download, but you can grab models from the internet. We have a protocol for that. So it can be a 3D scan. Of course, it matters how good your 3D scan is for the city, but it can be a real sort of environment. We can add pedestrians. We can add traffic. I'll show this operational in a couple of minutes as well. I'll just prepare my controls over here. Okay, so yeah, here we can see some pedestrians crossing. And all these can be areas of interest, objects of interest, right? So you can know when you look at these different objects. And like here we have a 360 scenario. We're recording some EEG data at the same time. Again, everything's synchronized with acknowledge. We can have inside objects of interest, and we can put these sort of placeholder objects, like, so when the person is driving, in this case, driving inside I'll stop for a second, the video, just a second. So I'll go to that specific point here where we were. Okay, yeah, sometimes it's a bit tricky with all the buttons that are there. Okay, so we can see here that we can look at specific objects that people looked at, like the McDonald's logo. Okay, and then we'll keep going. We can get information about different objects in the environment, how much time was spent looking at them, how many times people look at them. So this could include pedestrians, could include user interface elements like the dashboard, could be traffic lights, stop lights. Because it's VR, we can configure all these things. And we get information about head movement, we get information about eye tracking, pupil diameter, etc. And then we can get replay. So this is very, very cool that we can see exactly what happened. We can see the heat map, what were the areas when the person was looking at, and we can view this in, we also have, of course, airplane simulation. And yeah, these are different cars. This is how we can really dial in changes into the code, and we'll go into that in a second. Okay, so now let's show some examples. I'll go ahead and put on HMD. Okay, and let's escape out of here. And okay, I'll go into the software. Let me fire up the HMD. Okay. Now I'm going to show you here now simply being inside a car first off, and I'm going to do this with the HMD. This is the general interface where we can load different environments, objects. We can get eye tracking data. We can send markers to acknowledge in real time, so they can pop up as we're performing the experiment. We can record the screen. So we'll go ahead and make sure here that we have the right model, which is this Jeep model. And then we can select which objects are targets for the eye tracking. Of course, we can easily even make objects grabbable, but that's usually not a consideration in a car sort of scenario. So we'll go ahead and fire this up, and I'm going to use the MetaQuest Pro. That's what I'm connected to right now. So there we go. And I could enter participant information, but I will not do that. So let me just go ahead and change my position in the car, like this. Okay. So now what you can also see by that green dot is where I'm looking. So whether I'm looking at the rear view mirror or looking at the the glass, it will tell you what is it that I'm currently looking at. Okay, so this data can then go into Knowledge. You can use it to get some statistics out of it. Okay, so you can load in different sort of models, and it can be in VR. Now we can also be driving in VR, but I want to show you another mode. So here I have a controller, just a joystick, and we'll go ahead and do some driving with some traffic. So we'll be in the city scene, and yeah, I'll just go ahead and continue. And what I'm gonna do is use a driving controller in desktop mode. Okay, so let's go ahead and begin here. Here we are, and I'll just forwards. So I just got hit by a car. I don't know if you were able to hear that sound. I can just do another head-on collision here. Okay, so we can see, we can have these sort of events. Right now, I don't have any eye tracking or anything enabled, but you know, can be driving around the city and things can be happening. Okay, and we actually have support now for Tobii and iLogic eye trackers. So you could do this also on a desktop with an eye tracking bar, so we can know what you were looking at. Now here's another example where we can drive using ramps, so using physics engine in the software. So this is going to be a different world now. Go ahead. So we'll begin the experiment, and I'm gonna break the rules a little bit. Let's come over here, maybe even like go over to this ramp right here. Okay, and let me back up a little bit and try to get onto the ramp. So the sound may not be coming across very nicely. I'm going very, very fast now. So as you can see, I'm going up and down. I can try to fall down here, and boom, I'm down on the ground. Okay, so I just wanted to show you different kind of scenarios, and you can easily change what they are. So we can just come over here on the configuration, and we just change the name of the model, like what will be the environment. So you download something from the internet and use another one. You change the name of the car, change the name of the engine sound, and here there is a car module where we can change some parameters for acceleration, speed, deceleration, etc. So there is a lot more that can be said about what can be done with the virtual reality platform. But in summary, we have a solution that really allows lots of flexibility. It's kind of really designed for research, and it's integrated with all the physiological data, so we can be sending data at the same time into Acknowledge. And in the interest of time, I'm not doing that right now, but we have, again, webinars that demonstrate that. So I believe that brings us now to the end of the presentation, and I will leave it to Brenda now and any questions that there may be.
Okay, thank you so much, Alex and Sanjay. Really great presentation. I know you guys both did a lot of work on this, this presentation for today's webinar. So really appreciate all your time. I do have a couple of questions, but before I get there, I want to just share my screen real quick and tell you that we host webinars almost every month of the year, and you can visit our website, biopac.com/webinars. And scroll down and see all of the topics we've hosted over the years, and you can watch them on demand at your convenience. Also, if you scroll down to any page of our website, you can click in to see who your local sales representative is. And if you click this button, you can fill out a form and it'll immediately send them an email. Mine is Amy because I am in California. And then also, I promised that I would share the workshop URL and QR code. Oh, it looks like that got cut off a little bit, but you can just scan that QR code if you're interested in hosting a workshop or attending a workshop in your area. Go ahead and scan this, fill out that form, and we'll work on that for you. Okay, so now on to our Q&A. Let me get back to my questions here. I've been answering some questions live. Ina had asked a question about, I know you already showed this, but you can create other environments besides the driving environment, other tasks, for example, playing cards with someone in VR.
Yeah, so there's quite a lot of, as I said, there's about 100 different templates. There's shopping scenarios, there's phobia environments, there's fear of heights. There's really quite a lot of them, but then the point is that since it's completely flexible, you can go to resource sites such as Sketchfab and grab 3D models, put them inside. I really recommend watching our webinars on that. And one point I forgot to make, which is important, is that we are able to grab from the headset also the face tracking data. And all that face tracking data is saved. It can also go straight over lab streaming layer into Acknowledge if we want. So there's a whole lot of information that's coming in, synchronized with the physiological data, like when something happens, when you hit a car, when you're maybe too close to something, and then the eye tracking data, what are you looking at, the face tracking data, etc. So it's up to now you as the researchers to take this and run with it and make some cool things happen.
Okay, great. Sorry, I'm just researching. So I know we had a question. Andre had asked about customizing event marks for Research Ring. I know we can do that in Acknowledge. I'm not sure if we can do it in Res Ring or not. It's something that we can research and get back to you on, Andre. Or do you know off the top of your head, Alex? Can in the app
Why I missed the first part of the question to customize?
customizing event marks, so you label them with different
Yeah, currently they're not. Currently, it's just an event mark. There are other ways in which you can get event marks also, but again, yes, that's something that people have asked for. Right now, it's just an event mark. So I think it's good to keep in touch
yeah.
if and when something happens.
We're
Yeah.
always developing and improving everything, so it's good to know about your interests. And then the last question, I know you addressed this with Ladislav. How do you synchronize with other devices besides what you showed in this presentation,
Yeah,
using
I
potentially
think
OSL?
this was an important question. The question was about things like maybe some vehicle data, like pedal position, steering wheel angle, etc. So I think I don't know how it would work. I guess for every car it may be a little bit different. But if you can get that data over to us via lab streaming layer, our software can receive data over lab streaming layer. It will be aligned with all the physiological data and everything else, and that's probably the best way to go, right? So it will be just extra channels coming in. So you have your skin conductance, you have heart rate, etc., and then you have that data coming in. So just get that data over to us in LSL format, and that should work.
Okay, so I just got a new question. Okay, let's see if I can understand this. With regards to Acknowledge platform, are cognitive states such as distraction validated to be used for laboratory research?
Yeah, so there is a paper that I believe we have on the page. If not, we probably put it in the FAQ for the webinar. But there is a publication about the validation of the metrics. So it's using there's validation of the algorithm, and it's been used quite a bit in academic research.
Okay. Okay,
Yeah.
well, that is a wrap. Thank you guys so much. Again, I know it's a lot of work to put these things on, so appreciate your time. I just have some closing comments here. Today's webinar was recorded. We'll email you a link to the recording and the slides. When you close the webinar window, you'll see a survey. Please complete it so we have your feedback. Also, please visit biopac.com for additional references, including screencasts on specific features and analysis tools, application notes, Alex's published some scripts for VR on our site. Lots of great information there. Of course, there's information about upcoming webinars and events for the spring. Anything else before we conclude, Alex and Sanjay?
There's a small point. The videos Alex showed on VR, they appear jerky, but the reason for that is because the refresh rate is not matching with GoToWebinar. So in reality, they are very smooth and very.
Yeah, yeah. Thank you, Sanjay. That's a good point. We always need